last lesson, we learned how to graph using transformations, and that works great when the functions are written in a specific way that lends itself to that. But now we need to learn how to graph other style functions. So if you look at this first example here, number 1, you'll see that there's an x on the top and the bottom. And yesterday's lesson didn't deal with anything where x was on the top. So we need to have another method of graphing that will allow us to do problems that look like this. All right, and so the method we use is called Ratey. That's an acronym, and it just helps you remember what are all the important things you need to know to be able to graph these. All right, so I've provided in Google Classroom a sheet that has an in-depth explanation of what each letter means and why it is. Here I'm going to briefly go over it on this first example, and then we'll just kind of roll from there. All right, so number 1, we have our equation here. So the R stands for roots. All right, and in a fraction, roots are where y is equal to 0. So a fraction is equal to 0 when the numerator is equal to 0. So the R, the shorthand way, is just set the numerator equal to 0. So in this case, we don't even have to do any work here. X equals 0. That's it. Okay, a root is a point on the graph, so I would like you to write it as a point. 0, 0. All right, x is 0, and then we know a root, the y is always 0. A stands for asymptotes, and these are specifically the vertical asymptotes. All right, and vertical asymptotes come where this fraction is undefined. So fractions are undefined when the denominator is equal to 0. So that's the easy way to remember this one. Set the denominator equal to 0. So we set x plus 3 equal to 0. Got to do a little algebra here. We subtract that 3 over, so we get x is equal to negative 3. An asymptote is a line, so it gets a whole equation. So that's the whole thing right there. So we have a point on the graph now, we have an asymptote. T stands for togetherness. Togetherness is when both curves are right next to each other. All right, so if you remember from our lesson yesterday that they were mostly like two separate, trying to get the camera right here, two separate curves like this. All right, togetherness means there are two curves right next to each other like this. All right, and this only happens when you have a perfect square in the denominator. So if this had parentheses around it with a squared, that would be togetherness. But there is no square here, so we just write none. There is no togetherness. All right, the toughest one is the E. E stands for end behavior. The way you can think of end behavior on these problems is the horizontal asymptote. That's what end behavior is. That's how it shows up on the graph, is as a horizontal asymptote. There are 3 categories to be able to tell. All right, you're either going to have a top-heavy, a bottom-heavy, or a balanced. Okay, so that's your first job. Figure out if it's top-heavy, bottom-heavy, or balanced. The way you figure that out is by looking at the exponents on the variables, the biggest one. All right, so the biggest exponent here is a 1. The biggest exponent here is also a 1. So if they're the same number, that's balanced. So I'm going to write BAL for balanced. And balanced ones, the way you figure it out, it's always going to be y equals, because it's a horizontal line, y equals, and the balanced ones you have to divide the coefficients. Don't divide the exponents, divide the coefficients in front of those x's. So in this case, they happen to be the same. They're both 1s as well, and 1 divided by 1 is 1. So your horizontal asymptote on this graph is y equals 1. Last but not least is our y-intercept. So y-intercept is where you plug in 0 for x. All right, so y-intercept is where x equals 0. All right, so if I plug in 0 for x, I get 0 over 3, which is 0. So 0, 0 is the y-intercept. And we actually already knew that because our root was 0, 0. Anytime you get 0, 0 as a root, that's also going to be your y-intercept. All right, so now we have some info. We can start putting stuff on the graph. So we have a point here at 0, 0. So we'll put that point, x equals negative 3. So let's put a dotted line, vertical line out here at negative 3. All right, we have y equals 1. So our horizontal asymptote at y equals 1. Okay, and then so one of our curves has to be in this bottom right quadrant because it has to go through our root. So get close to that asymptote, go through the roots, and get close to this asymptote over here. We're not going for perfection here, we just want the graphs to be in the right quadrants and to go through the important points that we found. All right, to figure out the other curve, it has to be on the left side of the asymptote. We can't have a curve up here because then it wouldn't be a function. It would no longer pass the vertical line test. So that's not a possibility. It's either top or bottom over here. Okay, and the way you figure out the second curve is by the togetherness. If there is togetherness, we would graph it on the bottom because it'd be right next to this one. But we don't have togetherness here. So our other curve has to be in the top left, like that. All right, moving on to number 2. All right, so this one, we'll go a little faster, hopefully. So for our roots, we set the numerator equal to 0. If there is no x in the numerator, like this one, then you don't have a root. You just write none, because we can't set 5 equal to 0. That doesn't make sense. That's just false. All right, asymptotes. We set our denominator equal to 0. You actually do not have to do the squared part. Just pull out whatever's inside the parentheses and set that equal to 0. And we add the 2 over, so we get x equals 2 as our vertical asymptote. All right, togetherness. So remember what we talked about in the last problem. If you had a parentheses with a squared, then yes, we have togetherness. So we're going to write yes. Okay, and I want to say yes at. Where does this togetherness occur? It always occurs at the asymptote. Okay, so this is going to be yes at x equals 2. All right, in behavior. So this is our top heavy, bottom heavy balanced. So if we look at our exponent on the top, there is no x up there. That means that's a 0. On the bottom, we have an x squared. If we were to multiply this out, we would have an x squared term. So we have a 2 on the bottom, a 0 on the top. That is bottom heavy. Bottom heavy is easy. Automatically, y equals 0 every time. You don't have to do any math. You just memorize that. Automatically, y equals 0. All right, last step is going to be our y-intercept. So this is where we plug in 0 for x. So that's going to be y equals 5 over 0 minus 2 squared. So we have 5 over 0 minus 2 is negative 2, but then we square it and we get 4, positive 4. So our y-intercept is 0, 5/4. All right, so let's put this stuff on a graph over here. So we've got x equals 2 as our vertical asymptote. Y equals 0 as our horizontal asymptote. That's the x-axis. And then 0, 5/4, which is a little bit bigger than 1. So right there. All right, so one of my curves has to go in this top left quadrant because it has to go through our y-intercept. Okay, the other curve cannot go in the bottom right here because that would fail the vertical line test. So one of these two on the right side. And since we do have togetherness, sometimes I like to write a T. On day 2, we're going to do problems where some asymptotes have togetherness and other ones don't. So it's good to label which ones have it. So since there is togetherness on this one, our second curve has to be right next to it. So they're both going to be on the top this time. Like that. All right. So I would like for y'all to give this one a try on your own and see how you do. Unpause the video when you're done and check your... All right, so we set our numerator equal to 0 for the root, and we get x equals 3. Remember to write your root as a point, 3, 0. Y value always 0 on a root. Set your denominator equal to 0 for the asymptote. So you end up with x equals -2. That's a line, so you get the equation there. No togetherness on this one, no perfect squares on the denominator. In behavior, we're back to a balanced. Look at the exponents, they're both 1. So balanced. And so this is where we divide the coefficients, which are also both 1. 1 divided by 1 is 1, so y equals 1. And then for our y-intercept, we plug in 0 for x. So 0 minus 3 over 0 plus 2. That is -3/2. So my y-intercept is 0, -3/2. All right, let's plot all this info over here on our graph. So 3, 0. negative 3 halves is negative 1.5. We have our vertical asymptote at x equals negative 2. And our horizontal asymptote at y equals 1. Alright, so one curve is bottom right because it has to go through both our y-intercept and our root. And no togetherness means our other curve would have to go in the top left. Alright, moving along. So next one we have a little factoring to do. So x squared plus 6x plus 9, factor that out. X times x, plus sign, numbers that multiply to 9 add up to 6 are 3 and 3. So we can rewrite this as x minus 4 over x plus 3 squared. Since they were the same thing, write it as a squared. That is actually important because of the togetherness that we're going to see. Alright, so numerator is going to be set equal to 0 for the root. X equals 4. Write it as a point, 4, 0. Alright, asymptotes set our denominator equal to 0. And remember, you don't have to include the square. Just pull out that part inside the parentheses. So x equals negative 3. Togetherness is a yes, because we have a perfect square at x equals negative 3. End behavior, this time we have a 1 exponent on top and a 2 exponent on bottom. That is bottom heavy. Automatically y equals 0. And then y-intercept we plug in 0 for x. So 0 minus 4 over 0 plus 3 squared. So that's going to be negative 4 over 9. So 0 comma negative 4 ninths. Alright, let's plot all of these on our graph over here. So we have a point at 4, 0. We have our vertical asymptote at x equals negative 3. Sorry for the wavy line there. We have a horizontal asymptote. Let's put our t above that for togetherness as well. We have our horizontal asymptote at y equals 0, which is the x-axis. And we have our y-intercept at 0, negative 4 ninths. Pretty close to a half, so we'll put it there. Alright, so you're going to see something weird happen here. We talked about asymptotes in our lesson in 8-3, and I said you're never allowed to touch or cross an asymptote, which is almost always true, except for in this case. Anytime you have a root on an asymptote, it is going to cross through that asymptote. This will only ever happen on a horizontal asymptote. You should never cross a vertical, ever. Alright, that's a hard rule. Alright, horizontal asymptotes, when there's a root there, it will pass through. So this is what this is going to look like. It's going to go up here through our y-intercept, going to pass through that asymptote. It does a little bubble up like this, and then it comes right back down, and it follows along that asymptote as close as possible, but on the top side now instead of the bottom side. Since we have togetherness at this asymptote, our other curve has to go like this. This one will not go through the asymptote because there's no root over here to go through. Alright, so I'm running out of time on this video, so you'll have to tune into the next one to see the last two problems. On here, more of the same. Number 6 does have something a little different, so definitely look on there before you try the entire assignment. And I'll see you next time.